All the quantities that can be measured are called physical quantities, like mass, length, time and temperature. But what is a physical quantity? If a quantity possesses these two properties, then it is a physical quantity. Its numerical magnitude and the unit in which it is measured. If we say that the height of a student is 165 centimeters, then it is representing both the properties of a physical quantity, i.e. 165 is the numerical magnitude, while centimeters is the unit in which the height is measured. Remember, if we only state height as 165, then it is not a physical quantity, since it does not tell us about the unit in which it is measured. So it is a must for physical quantity to have both magnitude as well as unit. Physical quantities are divided into two categories: base quantities. Base quantities form the base or foundation of other physical quantities. In other words, the quantities are the basis with which derived quantities are expressed. These quantities are length, mass, time, temperature, intensity of light, electric current, and the amount of a substance. Derived quantities. Derived quantities, therefore, are those which are expressed in terms of base quantities. These quantities include area, volume, velocity, acceleration, force, pressure, momentum, electric charge, electric induction, etc. Before talking about the units which are associated with base and derived quantities, we need to know about the universally adopted system of units for physical quantities. This is to be noted that measuring does not always involve counting. Like if we need milk, we need to understand what quantity of milk is required. Similarly, to describe the physical quantities, a standard is required with which the quantities could be compared and expressed. This standard in physics is known as a unit. By that time, it was crucial so that the knowledge and findings with the advancement of fields could be shared universally by adopting some known standards. In this context, during the 11th General Conference on Weights and Measures held in Paris in 1960, a universal international system of units was accepted. This system is commonly referred to as SI, System International. Now, coming back to the base and derived quantities, we have understood about these quantities. Now, we will have a look at the units in which these are measured. Base units. The units used to measure base quantities are called base units. We now know that base quantities are 7 in number. But in what units these quantities are measured? Well, length quantity is measured in meter. Time is measured in second. Mass in kilogram. Electric current in ampere. Temperature in Kelvin. Amount of substance in mole. And intensity of light in candela. Derived units. The units used to measure derived quantities are called derived units. They are defined in terms of base units. We get them by multiplying or dividing one or more base unit with each other. For example, the unit for area is square meter, and for volume is cubic meter, which are based on the unit of length. Some derived units and their symbols are as follows. Velocity, which is measured in meter per second. Acceleration, measured in meter per second squared. Force, in meter kilogram per second squared, or termed as Newton. Pressure, in Pascal, or kilogram per meter second squared. Momentum, in meter kilogram per second. Charge, in Coulomb or ampere second, and magnetic flux density, in Tesla, or kilogram per second squared ampere. Let's take a deeper look into these. How can we measure quantities, like lengths, with proper accuracy? There are several ways. Meter rule. It is used to measure the length or distance between any 2 points. As the name indicates, it is 1 meter in length, which, by convention, divided into 100 centimeters. Each centimeter consists of 10 small divisions, known as millimeter. Thus, the smallest reading that a meter rule can give is 1 millimeter, also known as its least count. To have accurate measurements using a meter rule, we must keep our eyes directly above the reading points. Measuring tape. It is used by carpenters and builders to measure a greater length, usually in meter, centimeter, and inches. This means 1 centimetre is the least count of measuring tape. The same as in meter rule, to measure accurately using a measuring tape, we must keep our eyes directly above the reading point. Vernier caliper. To obtain an accuracy of more than 1 millimetre in our measurements, we use a vernier caliper. It has a main scale and a vernier scale, parts of vernier caliper located on its jaw. A vernier scale has 10 divisions on it, and each division equals 0.9 millimetres. Thus, the difference of one main scale division and one vernier scale division equals 0.1 millimetre, and is taken as its least count. To gain accurate measurement, we need to find the zero error of the instrument if present. This will help to achieve accurate reading by adding or subtracting the zero error value from the obtained readings. Screw gauge or micrometer screw. It is used to measure small lengths with greater accuracy than a vernier caliper. The least count of a screw gauge is 0.01 millimetres. It also requires us to find the zero error of the screw gauge to accurately measure the length. The zero error value will then be used to correct the obtained readings.